On this Ram 1500 Classic with the 5.7 Hemi P0440 is a general EVAP system failure. In plain terms, the PCM may be trying to pull the EVAP system into vacuum and confirm the ESIM switch response, but it can't get the response it expects. The truck may simply turn the MIL on, and the driver may not notice much else. Broadly, the fault area can include purge vacuum supply, EVAP line restrictions, vent hose or filter restriction, ESIM mounting or switch operation, a large EVAP leak, ESIM signal or ground issues, the purge solenoid, or in some cases the PCM. Before getting deep into testing, start with the basic system checks, then check for any applicable service bulletins or PCM flash updates related to this code. If an update or bulletin applies, handle that first, then come back and test the EVAP system. Before judging the system, make sure you're working under conditions where this monitor can run. Treat the running conditions as monitor gates. It needs the right cold start relationship between coolant and ambient temperature, where the difference between the ECT and AAT inputs is less than 10 degrees C, 19 degrees F. Fuel level has to be between 12% and 88%. Manifold vacuum has to meet the calculated requirement, and ambient temperature has to be between 4 degrees C and 35 degrees C, 40 degrees F, and 95 degrees F. For the monitor logic, an engine on or drive cycle is valid for a minimum of 2-5 minutes, and the engine on timer is clipped to a maximum of 26 minutes on any given trip. After key off, there is a 12-minute delay time where the PCM will ignore ESIM switch input, and the engine off event can run to a maximum time of 5 hours without an ESIM switch closure during the event. The monitor increments accumulation fail timers until both calibrated thresholds are reached: engine on 100 minutes and engine off 70 hours. Also remember that temperature swings can fool the test. A rapid temperature change can create vacuum fast enough to hide a leak, or vapor buildup can make a sealed system look like it is losing vacuum too fast. The ESIM switch response is the center of this P0440 path. When system vacuum reaches between -187 Pa and -250 Pa, it acts on the diaphragm and closes the vacuum switch. The ESIM signal will typically be a 12.0 volt or 5.0 volt signal depending on the vehicle, and the voltage signals can vary between vehicles and may be somewhere between 5.0 and 12.0 volts. For P0440, if the switch does not close at all during purging, because the switch is stuck open or vacuum cannot be created below -250 Pa within the calibrated time, that is treated as a general evaporative system failure. Next, run a manual EVAP leak evaluation with the scan tool data visible. Watch purge duty cycle percent, ESIM switch state, and fuel tank pressure in Pa. For best results, the fuel tank should be less than 95% of fuel tank capacity. This evaluation is built around 5 phases, and the important part is to document the ESIM state and FTP sensor reading at each phase before deciding where the fault is. Phase 1 is the zero reference check for the FTP sensor. With the ignition on, vent the system to atmosphere and watch the data. You can vent it by removing the gas cap, opening the capless filler, or actuating the purge solenoid for 1 minute with the scan tool. Document the ESIM switch state and the FTP sensor reading. The ESIM switch should be open, and the FTP sensor should read near 0. Whatever the vented FTP reading is, use that as the zero reference, even if it is not exactly 0. If the ESIM switch reads closed here, think about a signal circuit shorted to ground, an ESIM switch stuck closed. Or, if you use the purge solenoid to vent it and FTP did not change, a purge solenoid that did not open. Phase 2 is a non-intrusive check. With the ignition on and the engine not running, let the closed system sit and monitor it for 2-3 minutes. The FTP reading should start to slowly move either positive or negative. Do not stop just because it looks normal at this point. If the reading changes more than 200 Pa in 1 minute, the system is too unstable to accurately test. If it stays steady, that can mean a leak. Or it can simply mean the system temperature is too stable to create a pressure change. If the pressure change is very rapid, the temperature change is too large and the result is invalid. Either way, use this phase to understand stability, then keep going. Phase 3 checks for a purge solenoid leak. Start the engine, and while the purge solenoid is off, document the ESIM switch state and FTP sensor reading within 5-10 seconds after startup. A small amount of vacuum is normal from fuel being pulled from the tank, typically between approximately -25 and -50 Pa. If vacuum appears instantly after startup near or below the ESIM regulation point of -500 Pa, the purge solenoid is leaking. Phase 4 is where you build the intrusive test vacuum and check ESIM switch function. Let purging become active long enough to create maximum vacuum and stabilize, then shut the engine off right after maximum vacuum is reached. The recommended method is to turn the engine off after recording Phase 3, run the scan tool purge vapor routine, follow the prompts, then return to the data display once vacuum is created. In a normal response, FTP should drop quickly to approximately -600 Pa, and the ESIM switch should change to closed. If FTP drops as expected but the ESIM switch does not close, the switch may be stuck open, or the ESIM signal or ground circuit may be open. If the ESIM switch closes but FTP changes very little or not at all, suspect a restriction between the canister and FTP sensor or a stuck sensor. Verify 5-volt supply at the sensor before condemning the sensor. If the ESIM switch does not close and FTP barely changes, you may be dealing with a very large leak or a purge solenoid that is not opening when commanded. If the vacuum is 2 to 3 times the expected reading, look for a plugged canister vent hose or fresh air filter, or an ESIM vacuum vent valve stuck closed. That kind of restriction can also show up as difficulty filling the fuel tank. Phase 5 is the intrusive leak check. Once maximum vacuum is created and stable, turn the engine off and keep watching the FTP sensor and ESIM switch for another 3-4 minutes. Document the readings immediately after shutdown and again after 3-4 minutes. The FTP sensor reading should quickly return to the vacuum relief regulation point, approximately -500 Pa, and stabilize. Vacuum should stay below approximately -250 Pa, and the ESIM switch should remain closed during that additional monitoring time. If FTP rises quickly near 0 or above -250 Pa and the ESIM switch opens within the 3-4 minutes, the system has a leak, so move into leak testing. If every phase hit the expected results, the system is most likely not leaking at that moment. Possible false failures include software issues, debris that was temporarily stuck in the purge solenoid or ESIM relief valves and has since cleared, or an ESIM that is not mounted correctly with the switch at the 3 o'clock position. If Phase 5 points to a leak, choose how you want to isolate it. You can test the whole EVAP system as one assembly, or you can split the system at the charcoal canister and test each side. Either approach is valid. Just keep the decision clean so the readings point you in the right direction. For the whole system method, use the yield kit and accessory 8440C. Connect power and ground to the battery, connect shop air, set the smoke and air control to AIR, and use the remote start. Block the tester AIR supply tip while pressing remote start and calibrate the red flag if needed. Then connect service adapter 8440 480P to the ESIM vent hose. Connect the AIR supply tip to the adapter. Turn on airflow and compare the flow meter indicator ball to the red flag. Depending on fuel level and venting configuration, it can take several minutes to fill the system. If the ball drops to the bottom of the airflow meter or below the red flag, the rest of the system is sealed, so the leak is coming from the vent valves inside the ESIM. Replace the ESIM. If the ball stays above the red flag, the leak is elsewhere in the system. Use smoke, a hydrocarbon sniffer, or a bubble test to find it. Then repair or replace the leaking component. If you split the system, remove the canister tube from the charcoal canister and attach a hand vacuum pump to the canister fitting. Pump it until the ESIM switch closes. Then monitor ESIM switch state with the scan tool for up to 10 minutes. If the ESIM switch stays closed for a minimum of 5 minutes, the leak is on the fuel tank side. If it does not stay closed for a minimum of 5 minutes, the leak is on the fresh air canister side. For the fuel tank side, use the ELD kit and accessory 8400C. Connect power and ground to the battery, connect shop air, set the control to smoke, attach the black hose to the canister tube, and use the remote button to fill the fuel tank side with smoke. Then find the leak using smoke, a hydrocarbon sniffer, or a bubble test, and repair the leak you find. To check for an internal purge solenoid leak, remove the manifold hose from the purge solenoid, fill the system with smoke, and look for smoke coming through the purge solenoid. If smoke is present through the purge solenoid, replace the purge solenoid. For the fresh air side, use the ELD kit and accessory 8400C. Connect power and ground to the battery, connect shop air, set the control to AIR, use the remote start, block the AIR supply tip while pressing remote start, and calibrate the red flag if needed. Connect service adapter 8440 to the ESIM vent hose, connect the AIR supply tip to the adapter, activate airflow, and compare the indicator ball to the red flag. If the ball drops to the bottom of the airflow meter or below the red flag, replace the ESIM. If the ball stays above the red flag, the leak is elsewhere in the system. Use smoke, a hydrocarbon sniffer, or a bubble test, then repair or replace the leaking component. As with the other side, if smoke comes through the purge solenoid during the purge solenoid internal leak check, replace the purge solenoid. Keep verification separate from the leak search. After the leak is repaired, or after replacing a supported failed component from these tests, run the intrusive leak evaluation again. The goal is to confirm the EVAP system now builds and holds the expected vacuum response, the ESIM switch behaves correctly, and P0440 stays gone. The takeaway: don't guess at this code. Prove the zero reference, prove purge behavior, prove ESIM response, then isolate the leak path. For more diagnostic training, visit stepdiagnostics.com.